CBA. And now the question is, find the forcing member AC, BA, and BC. When they say solve this truss or analyze this truss, that means that find everything, including the external reaction at C, pin A, you have AX, AY, two components, right? And then also internal loading at this member, and this member, three members. So, if I ask you to use method of joints to solve this problem. So again, you know that you have the 5 steps, but the systems are the joints, right? So you don't think about how to choose a system. Systems are joints, C, A, B. Let's just start with C. C. So you draw the dash line, round it, find surface force, and then body force, and then you're done with the FED. Now consider this pin here is like that. There is a pin that is going through these two bars. So these two bars have the end like that. You put it on each other, and the pin goes through that. So this is my system here. So I try to derive FED. So the first thing I do, I pick a point and start walking. The first one I caught is this force inside this member that is applying to pin C, right? Do I know it? No. So I have to introduce a parameter like a variable. The way I do it, I number the bars. So 1, 2, 3. You can say force in AC, FAC, FBC, FBA. It doesn't matter, it's your choice. But because that system is that way is a little bit more time consuming, I just number them, and then I only have F1, F2, F3. So the first thing, like when I walk on this thing, the first thing I caught, if this is my start point, right? The first thing I caught is this force in member 1 applied to the pin. What's the direction? Somewhere in the X, because this member is in the X. It's either to the right or to the left. I don't know because I haven't solved the truss, right? But initially I consider the tension positive. That means this member is taking this pin and pulling it to the left, and also according to Newton's third law, the pin is also applying a tension force to member 1. So I just choose the direction as long as it's in the X direction is valid. Positive or negative, you will find it in the solution. So I take this way, positive. And this is F1, right? Now continue walking. The next thing you call is F2. Again, tension positive, F2. This angle is 45. You continue walking, then you come back. No, you don't come back to this. Then the next thing you call is the C, the roller. What's the direction of force at C? CY. The roller, only in the Y, right? So CY. Then you come back to the start point. You're done with the surface force. Body force. Do I have body force for this tiny, weightless pin? No. Right? So this is my first FED. Now let's go draw FED for A. Using the same thing, I know that the next system is joint either A or B, because I'm doing method of joints. We're talking about method of joints. So the joints are the system. So I go to the next joint or next system, and I get this FED, F1, F3, AX, and AY. Now go to the last system, or joint number B, joint B, so you get 500, F2, F3, and this is 45 degree. That's all. Those are my free body diagram. Don't forget check mark it. So systems are all joints because this is method of joints. Free body diagram. And now I'll go ahead and write the equations. Here, summation of force in x0 gives me negative F2 cosine 45 negative F1 equal to 0. Summation of force in y direction 0. F2 sine 45 plus Cy equal to 0. What about the moment equation? I'm working on joint C. Is our equation for joint C. What about the moment equation? I know that for a two-dimensional system, how many equations do I have for a 2D system? You have 3 equations per system in 2D. And how many in 3D? 6 equations per system in 3D. So I know that in addition to summation of force in x and y, I have a summation of moment should be 0. I know that I have this. So what happens to this equation?
It disappears.
It's a null equation, useless. Because if you take point C as your center of moment coming from F2 with respect to C is 0. Moment coming from F1 is 0. Moment coming from Cy is 0. So summation of moment in fact is 0, is equal to 0. It's a null equation. So this is another point. In the method of joints, this is a method of joints, right? Method of joints. The first thing is systems are all joints or pins. The second thing is when you write equation, you have 2 equations per joint or system. This is specific to method of joints. So you don't even bother writing the third equation. So you just write 2 equations per joint. The reason for that is there is no friction, there is no movement in this. If there was a friction, then there was an unknown moment here, and we would have a moment equation too. But it's frictionless, so you don't have a moment here. So the third equation is automatically satisfied. You see that? So let's just not write the third equation, and then our job becomes easier. That's the reason I said Truss analysis is always easier than frame analysis. It's very easy in fact. Now let's go to this guy. Here you get a joint A. You get F1 plus AX is equal to 0. F3 plus AY equal to 0. And here, joint B, you get 500 plus F2 cosine 45 degree is equal to 0, and then F2 sine 45 negative F3 is equal to 0. Okay? Alright? So these are all my equations. How many equations do I have now?
6.
How many are those?
6.
6 on 6 equations. So I should be able to solve it, right? Now, don't forget this check mark that you put. Now you go to solve. Which one should I start with? Let's put some numbers here, some labels. Equation 1, 2, 3, 4, 5, 6. Which one should I start solving the problem? Equation number 5. So you get F2 is equal to 500 immediately divided by cosine. Right. Put in your calculator. Negative 500 divided by sine. Negative 7.1. Now, the next step. Now I got my F2. Now the next step could be this guy, right, to get Cy, or equation 6. Well, since you said 6, let's solve 6. So F3 is equal to negative sine 45 times F2. And F2 is 87.1. So I have F1, F2, and F3. Then I can solve this. Cy is negative sine 45 times F2, which is positive 500. And here, F1 is equal to negative cosine 45 times F2. She's equal to 500. AX negative F1 negative 500 and AY negative F3 negative 500. That's the solution. In fact, this is example 5.1. Example 5.1 in your book. So this is the simplest kind of truss that we can get because we only have 3 members. So as you can see, we got the forces in all members, not only force in all members, but also external reactions at point A and C. So the method of doing is a very comprehensive method because not only you get force in members, but also you get external reactions if you can solve the problem, okay? Now, remember, so we did solution except for verification. We verified every problem we solved with frames and other system frictions and everything. We actually did verification as much as we could. So how can I verify this problem? Like I got this answer, 500, 500, negative 707. How can I verify it? Is there any way that I can verify it?
Intuition.
Yeah, intuition. One way is because you have the answer in the book. One way of verification is go and compare it with the book. But let's say you don't have a solution manual. You use your intuition. So how can I use my intuition? Let's say this problem is given to me, and I have a loading like this, 500. How can I use intuition to verify the solution to this problem?
Compression and tension.
Yeah, compression and tension. So if you have 500, imagine you apply 500 force here. So the next thing happens is this member goes, I'm just drawing an exaggeration of this problem. Like that, you see that? So this member is going to be under compression. I'm not sure about these two members, but I'm pretty sure that this member should be under compression. So if my default for tension positive, because the default has said the force in these two members, the force that these two members apply to the pin is this way, that means the pin is pulling these two members this way, right? So if the default was tension positive, what should I get for F2? A negative number. Because this should be compression. So I must get a negative for F2. Then I go and look at the solution. F2 is a negative number. If you get a positive number, then something is terribly wrong. Then you have to go back and see what you have done. In fact, the last step is something very crucially useful, because it can tell you if you get a right or wrong number, right? So I just check mark it, and I did verification. Now, let's say, what if I'm only interested in external reactions? So let's say somebody gives you this truss, A, B, C, right? This is solve over. Somebody gives you this truss and say, find the reaction at point C and A, external reactions, not internal. So what I found here, F1, F2, F3 is the force inside each member. This is the internal force, right? And we use method of joints. Now, if somebody gives you this instruction and say, find the external reaction at point A and C, then what do you do? This is the from previous chapters. There's nothing new. So how do you find the external reaction at A and C? What's your choice of system?
Beam one.
Huh?
Beam one.
First of all, these are bars.
Bar.
As you can see, these are not beam because the thickness is very small. These are just bars, long bars. So you said that I should choose bar number one, right? So let's do that. If you choose bar number one, then if you draw a free body diagram, you get AX, AY, then CY, still F2. That's my FVD. The force coming from member number 2, the force coming from this reaction, CY, right? And the force coming member 1, but look, this is my system, so that's the interior. It's not external force. And here at A, I have AX, AY. How many unknowns do I have here?
4.
How many equations for this system?
3.
Can I solve it?
No.
So we go back. Choose the system. So in fact, the idea here is, I tell you, don't find F1, F2, F3. You don't need it. You just find the reaction at A and C. So what do you choose as a system?
Pins.
No, the pins or joints is to find the internal loading. If I just want to say find the external loading, what do you choose as system?
Entire thing.
The entire truss. You already did it before, right? So the entire truss, if I choose the entire truss as my system, equation and C. Write moment equation around A. What do you get for this system?
No.
Well, you know that
Leave out.
you have a CY here. These are the external loads. CY, CX. Actually, there is no X because it's roller. CY, AX, AY, and 500. These are my loading on the system. Now summation of moment around point A0. What do you get? CY times 2, positive or negative?
Positive.
Positive, and then 500 times 2, positive or negative?
Negative.
Negative is equal to 0. So CY is equal to 500. CY, I had it there, 500. I erased it. So the same result. But look, this method that we had before, what I'm trying to say, the choice of system is making all the difference. So later on in the exam, if I ask you, what's the difference between method of joint and section, or method of joint or 5 steps? In fact, you know that all these things are just a subclass of all 5-step algorithm. The difference is just in the system, the choice of system, right? So if you choose the choice of system, you can find CY with just one line, without going through the trouble of writing all these equations, right? Okay. Now let's go to another problem. Bar 1, 2, 3, 4, 5. So this truss is composed of 5 bars with this connectivity, and we have 2 external loads, 400 Newton, 600 Newton, point B and D. And then these are the connectivity for the reactions. So an A is set up on a roller and C into the wall. So the question is, find the portion all members. F1, F2, F5, and also CX, CY, and AY, which is just external reaction, external reactions. Also, I ask you to use method of joints to solve this problem. So what do you do? First, before I actually go to the method of joints, which is a subclass of 5-step algorithm, the system is the joint, right? Before I do that, I said let's find external reactions. AY, CX, CY. So how do you find external reactions? Take the whole thing as my system, right? And if I take the whole thing as system, draw FVD for that. Here. There you go. Everything inside this doesn't matter, so I don't even draw these parts here. So I would have AY here, and then 400 here, CXCY, no moment here, and then 600 here. What else? That's all. If I take the whole thing as a system, I only have AY here, CXCY here, 600, 400, and that's all. Right? Now, if I write a moment around, let's say I just want to find AY. So what should I do? I just want to find AY. Moment around C. So I get summation of moment around this C is 0. That would give me 400 times this distance, which is 380. Positive or negative? Positive. 0, 0, right? Then 600 times this distance, 4. Positive or negative? Positive. And finally, AY times 6 is equal to 0. How many equations, how many unknown in this one line? One equation, one unknown. So you can solve for AY, right? How do you find CX? Summation of force in the x direction. You see we have 3 equations here. Summation of force, x direction is 0. Then you get 600 plus CX, right, is equal to 0. So CX is equal to negative 600. And CY, summation of force in the y direction, you get CY. So the point is, these things are, we can find it, they're known. Check mark it. They're known because we can take the whole system and we can find it. Before we do method of joint, we can find the external reactions, right? Now let's do method of joints. Joint B, joint C, joint B. In the method of joint, the system are the joints. So I know what to do. I don't need to think what part of this should I take system. The joints are the system. So I put all the joints here and draw FBD. A, B, C, D. So what I have here at C is CX, CY, F5, F4. You see tension positive. I initially put tension force. If I get negative, that means it's compression. Right? F5, F4, and then I go to joint B. We have 600. F4, F3, and F2. F4, F3, F2. And B, you get F5, F3, F1, and then there is a 400. And at A, you get F2, that's it. So that's my FVD. This angle theta is arc tangent. This side over this. This side is 4 over 3. It's angle theta, which is equal to arc tangent 4 over 3. This is 3.1. So this angle is 53.1, 53.1, 53.1, 53.1. Now I'm ready to write the equations. And I know how many equations I have per joint?
3.
Well, 2, because we don't, the moment equation is null.
Oh, no.
You
Yeah.
see, it's frictionless. So I don't even bother writing it. That saves no time. So here I get at joint A, I get F2 plus F1 cosine 53.1 is equal to 0. F1 sine 53.1 plus AY is equal to 0. At joint B, you get 600 negative F3 cosine 53.1 negative F2 is equal to 0. F4 plus F3 sine 53.1 is equal to 0. Here you get joint C. You get Cx negative y is equal to 0. Cy Cy negative F4 is equal to 0. Joint B. Joint B. Then you get F5 plus F3 cosine 53.1 negative F4 cosine 53.1 is equal to 0, and then negative 400 negative F3 sine 53.1 negative F1 sine 53.1 is equal to 0. These are the equations. How many equations do you have?
6.
You say, how many joints do I have?
4. You're right.
And per joint, I have 2 equations, so 8 equations. How many unknowns? 8 unknowns, right? So in fact, I will be able to solve everything. If I can solve this system of equations somehow, I will be able to not only find the internal loading, the force in F1, F2, F3, F4, F5, but also the external reaction, the reaction at A and C, right? So method of joint is very systematic and general because it can solve everything. But the question is, can I solve these equations? Let's say I don't have these external reactions, Cy, Cx, and Ay. Let's say I don't have these guys. Can I solve these equations by hand? Or in other words, are these equations decoupled? That means do you get one equation, one unknown to start with? Because that's the trick. We always try to find a single one equation, one unknown, solve it and put in the previous equation. Back for substitution and solve for everything. Now, can I do that?
No.
No. But look, with the choice of entire thing as a system, I can find my AY, as I just mentioned before solving this problem. So in that case, if I get AY, now let's say you have AY, then can you solve the system or not by hand?
Yes.
So what equation do you start to solve first? Let's do some number here. So let's say this is 1, 2, 3, 4, 5, 6, 7, 8. So what equation do you start with?
4.
If you have AY,
Oh, AY.
7. Look, you get AY from here, the external, you know, the entire system, you get AY here, right? Now you have AY. What do you get solving that? F1. Now if you have F1, put it here, you get F2. Now if you get F2, put it here, you get F3. You get F3, put it here, you get F4. Do it at home. When you watch this video, do it at home. Solve it. Then you get F4, you get CY. In fact, if you already have CY from external reactions, from the choosing the entire thing of the system, you can verify. This must be equal to CY. It must be equal to F4. CY must be equal to F4. And now, you can go back here. You can put all these 4 and 3 from there to get F5. And then you're done. So, the point is here, choosing the entire thing as a system and finding the external reaction is a good pre-step before you solve the problem. First, find the external reactions because it gives you enough information so that you should be able to solve the system. Find the solve the system. All right.